through this question. Find the derivative of cos x from first principle. Okay, given function is cos x. So we have to find the derivative of cos x from first principle. That is by the definition of the derivative. Okay, so given function f of x is equal to cos x. Okay, f dash of x is equal to limit. It is the first principle. Okay, limit h tends to 0. F of x plus h minus f of x divided by h. Okay. So what is f of x plus h? F of x is cos x. So f of x plus h is cos of x plus h. Okay. Now let us substitute here. Limit. Here you can write df by dx or f dash of x. Okay. Derivative of f of x, f dash of x or df by dx. So that is equal to limit h tends to 0. F of x plus h is cos of x plus h minus f of x is cos x divided by h. So here we have to apply trigonometric identity, trigonometric formula, that is cos a minus cos b. It is of the form cos a minus cos b. We learned that in trigonometric function cos a minus cos b, that is equal to minus 2 sin a plus b by 2 into sin a minus b by 2. It is the formula. Remember, cos a minus cos b is equal to minus 2 sin a plus b by 2 sin into sin a minus b by 2. So here a is x plus h, b is x. So this will become limit h tends to 0 minus 2 sin a plus b. A is x plus h, b is x. So a plus b, x plus h plus x, that will become 2x plus h, right? 2x plus h by 2 into sin a minus b. X plus h minus x. So there x will cancel. So remaining h. So h by 2 divided by h. Okay. So it will become, yes, as denominator of denominator comes to numerator, these two can be here, right? So let us write it here. Limit h tends to 0 minus sin 2x plus h by 2 into sin h by 2 divided by h by 2, right? Because see, we know that denominator of denominator comes to numerator. So these two can be here. So that we will get the standard limit. Okay. That is equal to limit h tends to 0 minus sin 2x plus h divided by 2 into, see, this one we can write separate, right? So sin h by 2 divided by h by 2. Now apply the limit. Limit h tends to 0 minus sin 2x plus h divided by 2 into limit h tends to 0 sin h by 2 divided by h by 2. See, h tends to 0, that implies h by 2 tends to 0, right? See, now it is of the form limit x tends to 0 sin x by x. Isn't it? We studied that standard limit, limit x tends to, limit x tends to 0 sin x divided by x, that is equal to 1. Okay. Now it is of the form limit x tends to 0 sin x by x. See, here we can write the h by 2. See, because we know that h tends to 0 implies h by 2 tends to 0, right? If h tends to 0, if h is equal to 0, h by 2 is also 0. So here we can write limit h by 2 tends to 0 sin h by 2 divided by h by 2. So it is of the form, this one, standard limit. So its value is 1. Therefore, limit h tends to 0 minus sin 2x plus h divided by 2 into 1, that is equal to, now apply the limit here for this. So here put h is equal to 0 using direct substitution method. Put h is equal to 0, you will get 2x plus 0 by 2. So 2 will cancel, you will get minus sin x. So minus sin x. So minus sin x is the derivative of the function cos x. So in the same way, you can find the sin x, derivative of a sin x and the derivative of tan x, same form, same method. So you will get the derivative of all these 6 trigonometric functions using first principle. Next we are going to learn algebra of derivative of function. It's very important. So for that, let us take two functions f of x and g of x. F of x and g of x such that their derivatives are defined in a common domain. So let us write d by dx or derivative of f of x plus g of x, that is equal to derivative of f of x plus derivative of g of x. Okay, that is d by dx of f of x plus g of x, that is derivative of sum of two functions, that is equal to sum of derivative of two functions. Okay, that is the derivative of f of x plus g of x, or you can write d by dx, that is equal to d by dx of f of x plus d by dx of g of x. Okay, next is subtraction. D by dx of f of x minus g of x, that is equal to d by dx of f of x minus d by dx of g of x. Okay, next is product. D by dx of f of x into g of x, that is equal to, see here, product of two functions. Here we cannot write d by dx, that is d by dx of f of x into d by dx of g of x as limit, but here it is different. That is, for that, let us consider f of x as first function, g of x as second function. Okay, then its derivative of a product of two functions is first function, that is f of x, into derivative of second function, plus, okay, next is second function into, that is g of x, into derivative of first function, that is f of x. Okay, remember, very very important, it is called product rule. Okay, so product of, that is derivative of product of two functions is first function into derivative of second function. See, if you consider it is as first function and it is as second function, okay, so that is equal to first function into derivative of second function plus second function into derivative of first function, or derivative of f of x into g of x, that is equal to f of x into d by dx of g of x plus g of x into d by dx of f of x. Okay, next is about division. D by dx of f of x divided by g of x, here g of x not equal to 0. Okay, here also let us, okay, no problem, f of x by g of x, that is equal to, first is, it is the denominator, numerator, denominator, right? So here first is denominator, that is g of x into derivative of numerator d by dx of f of x minus, okay, minus, next numerator into, that is f of x into d by dx of denominator divided by whole divided, okay, whole divided by g of x, that is the square of denominator, okay, g of x whole square. So it's also very very important. It is called the quotient rule, it is called the product rule. Okay, so quotient rule is denominator into, that is derivative of numerator, denominator, that is two functions, division of two functions, that is equal to denominator into derivative of numerator minus numerator into derivative of denominator, okay, whole divided by square of denominator, that is d by dx of f of x by g of x is equal to g of x into d by dx of f of x minus f of x into d by dx of g of x whole divided by g of x whole square. Okay, so it is the quotient rule. So these four algebra of this derivative of function very important. So here it is, we see this sum and subtraction we can write directly, but here you have to study what is the product rule and the quotient rule. So these are very important. See, these formulas we have to apply for many problems. Okay. Now let us go through some questions. First question, find the derivative of 5x cube plus 3x minus 1 into x minus 1. See, given function f of x, that is equal to 5x cube plus 3x minus 1 into x minus 1. See, here it is not mentioned. You have to find the derivative of this function from the first principle. So you can apply the formulas and find. Okay. So here, first of all, let us expand this expression. That is 5x cube into x is 5x raised to 4. 5x cube into minus 1 is minus 5x cube. Okay. Then after that 3x into x plus 3x square. 3x into minus 1 minus 3x, minus 1 into x, minus 1 into minus 1 plus 1. Okay, now we have got this polynomial. So here we have to find this derivative. See, we have to apply one formula, that is, we have already learned that d by dx of x raised to n, that is derivative of x raised to n is equal to n into x raised to n minus 1, right? So here df by dx, okay, df by dx, that is equal to, here see subtraction and addition, right? So we know that derivative of sum of two functions or more than two functions, sum of two functions, that is equal to sum of derivative of two functions, right? So here also we can split the derivatives. That means, see, d by dx of actually 5x raised to 4 minus 5x cube plus 3x square minus 3x minus x plus 1, right? And split the derivative. Sum and subtraction. Therefore, you can split the derivative, that is d by dx of 5x raised to 4 minus d by dx of 5x cube plus d by dx of 3x square minus d by dx of 3x minus d by dx of x plus d by dx of 1. Okay, say one more thing, the derivative of a constant is 0. Okay, note it down, d by dx of a constant a, that is equal to 0. See, if you apply the first principle, you will get the answer 0. Okay, you just take f of x is equal to a constant a, then apply first principle method, you will get the derivative of a constant function x is 0. And one more thing, that is d by dx of a constant into f of x, okay, that is equal to lambda. Lambda is a constant, lambda into, we can take lambda outside as limit, okay, d by dx of f of x. Okay, so here now we can take this 5 outside. Okay, 5 into d by dx of x raised to 4 minus 5 into d by dx of x cube plus 3 into d by dx of x square minus 3 into d by dx of x minus, okay, d by dx of x plus, here it is 0. d by dx of a constant is 0. That is equal to 5 into, here we will apply this formula. Okay, that is derivative of x raised to n is equal to n into x raised to n minus 1. Okay, here n is a positive real number. So here x raised to 4, we can apply this formula. That is, here n is equal to 4. So 4 into x raised to 4 minus 1, that is 3. Okay, minus 5 into, here d by dx of x cube, n is equal to 3. So 3 into x raised to 3 minus 1, so x raised to 2, that is x square, plus 3 into, here x square, n is equal to 2, so 2 into x raised to 2 minus 1, that is 1, okay, minus 3 into d by dx of x, that is 1 itself, dx by dx, that is 1, or you can apply that formula. If n is equal to 1, that means 1 into x raised to 1 minus 1, that is 1 into x raised to 0, that is 1. So remember dx by dx is equal to 1 or d by dx of x is equal to 1. So it is 1 minus, okay, d by dx of x, that is 1 itself. Now here 20 x cube minus 15 x square plus 6x minus 4 is the answer. So it is the derivative of this given function. Next question is find the derivative of 2 by x plus 1 minus x square by 3x minus 1. Okay, first of all let us write it. Given function f of x is equal to 2 by x plus 1 minus x square by 3x minus 1. Okay, so we have to find the derivative, that is d by dx of f of x, that is equal to, see here, subtraction of two functions. So here let us take separate it, d by dx of 2 by x plus 1, okay, minus d by dx of x square by 3x minus 1. Okay, now next we can apply quotient rule. Okay, see here 2 divided by x plus 1. So here we can apply quotient rule to find the derivative, that is, see here denominator x plus 1 into, we know that d by dx of f of x divided by g of x, quotient rule, that is equal to g of x into d by dx of f of x minus f of x into, that is numerator, into d by dx of g of x whole divided by g of x whole square, right? So here also let us apply this quotient rule. Denominator into, that is x plus 1 into derivative of 2, that is d by dx of 2, okay, minus 2 into, that is f of x, okay, numerator, into d by dx of denominator x plus 1, okay, whole divided by square of denominator, that is x plus 1 whole square. Minus, next we will find this derivative. Here also it is of the, here also we have to find the derivative using by quotient rule, right? That is denominator 3x minus 1 into derivative of x square d by dx of x square minus x square into derivative of denominator d by dx of 3x minus 1 whole divided by square of the denominator, that is 3x minus 1 whole square. Okay, now let us find one by one. X plus 1 into d by dx of constant, derivative of a constant function is 0 itself, okay. So d by dx of 2 is 0 minus 2 into derivative of x plus 1. See, d by dx of x plus 1. d by dx of x plus 1 is nothing but d by dx of x plus d by dx of 1, okay. Applying sum, that is, we know that derivative of a sum of two functions, that is equal to sum of derivative of function, that is d by dx of f of x plus g of x, that is equal to d by dx of f of x plus d by dx of g of x, right. So here d by dx of x is 1 plus d by dx of 1 is 0, so the answer is 1, right, because d by dx of x or dx by dx, that is equal to 1, okay, plus d by dx of constant is 0. So here it is 1 divided by x plus 1 whole square minus 3x minus 1 into d by dx of x square. Apply this formula, d by dx of x raised to n is n into x raised to n minus 1, okay. So here d by dx of x square, n is equal to 2, so x square is nothing but 2 into x raised to 2 minus 1, that is 2 into x raised to 1, that is 2x, okay. So it is 2x minus x square into d by dx of 3x minus 1. d by dx of 3x minus 1. See, now it is of the form d by dx of f of x minus g of x, right? So we can write it as d by dx of 3x minus d by dx of 1, right? So d by dx of 3x, we can take 3 outside from the derivative, that is 3 into dx by dx, right? That is 3 into d by dx of x, right? So we can take this constant outside, minus d by dx of a constant function is 0. Okay, so 3 into dx by dx is 3 into 1 minus 0, that is 3. Okay, so here it is 3. Directly you can write, see, you can find d by dx of 3x minus 1, d by dx of 3x is, take 3 outside, so dx by dx is 1, so and d by dx of 1 is 0, so 3 minus 0, that is 3. Whole divided by 3x minus 1 whole square. Okay. Now, here it will become x plus 1 into 0, first term will become 0 and minus 2. So, minus 2 divided by x plus 1 whole square minus, here it is 3x minus 1 into 2x minus 3x square divided by 3x minus 1 whole square. Okay, that's all. The next question is, find the derivative of sin x into cos x. See, here given function is of the form product of two functions, right? So that is f of x is equal to sin x into cos x. It is of the form product of two functions. So here we will apply product rule. That is d by dx of f of x is equal to d by dx of sin x into cos x. Okay. Apply product rule. Consider first function, second function, first function as sin x, second function as cos x. So first function, that is sin x into derivative of cos x plus second function cos x into derivative of first function, that is equal to sin x into, here see we have already found derivative of cos x is minus sin x from first principle, right? So, and I told that we can find the same, in the same method we can find the derivative of sin x from first principle and we will get d by dx of sin x is equal to cos x. Okay, d by dx of cos x is equal to minus sin x, d by dx of sin x is equal to cos x. So apply here, d by dx of cos x is minus sin x plus cos x into d by dx of sin x is cos x, that is equal to minus sin square x plus cos square x, that is cos square x minus sin square x, that is nothing but cos 2x. Okay, trigonometry formula. Now let us go through next question. Find the derivative of x plus cos x divided by tan x. Given function is x plus cos x by tan x. So here we will apply a quotient rule. So before that you should know what is the derivative of tan x. You will find the derivative of tan x. See, either from the first principle or you can write just tan x as sin x by cos x. Here you will apply quotient rule and you will get the derivative of tan x is sec square x. Okay. We know that tan x is sin x by cos x. So apply quotient rule here. You will get derivative of tan x is sec square x. Okay. Now let us find the derivative of this function. F of x is equal to x plus cos x divided by tan x. Apply the quotient rule. So derivative of f of x d by dx of f of x is equal to, quotient rule is denominator into, that is tan x into derivative of numerator, that is x plus cos x minus numerator into x plus cos x into derivative of tan x, that is d by dx of tan x, okay, all divided by denominator whole square, that is tan x whole square, you can write tan square x. Okay, so here tan x into, let us take the derivative, d by dx of x plus cos x. D by dx of x plus cos x is d by dx of x plus d by dx of cos x. D by dx of x is 1. Okay, so 1 plus d by dx of cos x is minus sin x. Minus x plus cos x. See, you should be careful about plus and minus, otherwise your answer will be wrong. Okay, so here minus of, see here plus into minus. Okay, minus x plus cos x into d by dx of tan x. See, as I mentioned before, d by dx of tan x is sec square x whole divided by tan square x. That is tan x into 1 minus sin x minus sec square x into x plus cos x whole divided by tan square x. Okay, you can stop here. It is the derivative of given function.